Hey, what's up, guys? I was actually recording a video. My computer shut off. I accidentally turned it off with my foot. This is our corrupted video here. Obviously, we can't open it because it's corrupted, but yeah. Um, we're actually in the middle of looking at this problem here. So, we were going through here. We had done the problem of the day. We did hash map problem. I think we did this one. Then we did this one. Now we're back here. We're at our fourth problem. So, yeah, my bad. We're going to keep going, but I don't have the footage from before, so that's okay. Probably going to finish up here, probably like two more problems, and we're going to call it a day. So, we're going to do the Pokemon of the day again, just because, you know, I think it was a Ghastly, right? Ghastly Pokemon sound. Whoops, Pokemon sound. I'll do the Ghastly cry. My headset's turned off. Let's take a listen to that again. But yeah, that's our sound of the day. We're gonna go back to this problem. We were just looking at it. We have done this problem before. We did it in January. But for I in range length path, right? So we need to think about what we see, right? So we had our stuff open here. I was a little confused with kind of how to go about this problem. Path can't do nothing. So really, I think we need to go through and just add stuff that's alright. So, okay, if we can do if path I is equal to a slash, right? Then we can just append it, right? Stack.append path I, right? Okay, so we've done this one. A single period represents the current directory. A double period represents the previous directory. Do we just append the dot? We get rid of all the dots, right? Yeah, we get rid of all the dots. Okay. Let's just add the stuff. Okay, so if path is equal to this, we append, right? How to check if letter is if char is alpha numeric in Python. I can't remember. Is a letter. Is alphanumeric a letter? I thought it was. Is alpha, that's what I'm looking for. Is alpha. Okay, we can do if path I dot is alpha, then we can just stack dot append path I, right? We know that. If it's slash, else if it's a slash, then we can append it, right? Slash or okay. Dot a valid directory of file names. Any sequence of periods that does not match the rules above should be treated as a valid directory of file name. For example, or a valid directory of file names. Okay. exactly one slash. Path must not end with a slash unless it's the root directory. So we're gonna have some edge cases here. Path must not have any single or double. How do we know if it's a double? Because we're gonna be looking at this at the same time. So I think, actually it says here. The path parts. Loop through those parts. Oh, okay. Okay, so we need to actually, before we create the stack, we need to make the parts. So parts is equal to path.split. We can split it by the slash here. So let's get rid of this. Let's print the parts. Split it by slash. Oh, yo, what's up, bro? You going to Charleston? What? You going to Charleston today? No. Alright. Okay. We split it by the slashes. Okay, then what does it say? We split, loop through those parts, use the stack to build the valid directories. Okay, so we can do, okay, for I in parts, let's do for part in parts. Okay. If part dot is alpha, then we want to append that, right? Dot append part, right? We append a part, right? Slashes don't really exist, right? Because we split them by slashes. We can skip it if it's a dot dot, but if it's dot dot dot, Okay, maybe we should actually check because there's a lot of these, right? If path is equal, if part is equal to this, sorry, this, or part is equal to, I think there's a space, right? Because there was a space between some of them. Okay, maybe not. Equal to this, we just continue. Else if part is equal to dot dot dot, then we stack dot pop. Okay. Ah, bless me, bro. Oh my god. I believe the only thing really we need to do is just pop, right? If we see this, we pop. I guess if we see a dot, we continue. If we see a double dot, we pop. Otherwise, I think we just add everything else. Dot append part. Let's return our stack. Okay, we're not even appending anything. If part is equal to this, also if part is equal to this, else everything else, we just append the part. So we're not appending anything. Print parts. Shouldn't this work, dude? Part is equal to this, or this, continue. Part is equal. Everything else, I believe, is fair game, bro. Why is this returning nothing currently? What the fuck, dude? Oh, or part is equal to this. We continue. We have to check if its stack's not empty as well. Did that fix it? Okay, there we go. We get home. Expected home food. Okay, I believe now we need to stack.append. We add like a slash plus part. Okay. Return dot join. Get our stack. Okay. We have a slash. Okay. If stack. Okay, let's do, okay, if stack then we do, then we return, okay, else we return slash. There's something in it. Okay. This is definitely gonna be some error here, bro. Nope, that worked. Okay. Sweet. We did that problem. We're goated with the stack, bro. Goated. Okay. Let's do partition list. We've never solved this one, so. Give me the head of a linked list and a value x. Partition it such that all nodes less than x come before the nodes greater than or equal to x. Ooh. What are we returning? We return a list node. How can we solve this in place? This is a good problem. Okay. Oh, okay. I understand. Okay, so our x is 3, right? Given the head of a linked list and a value x, partition it such that all the nodes less than x come before the nodes greater than or equal to x. Okay. So we get a value, and we have to move every single value that's greater on this side on the other side. Okay. This is an interesting problem. Trying to think about how we can solve this. Definitely a tough problem. It's got a 58% acceptance rate. Okay. So I'm thinking, well, we have to keep looping until we get a pointer that is pointing to our x value, right? We need to find our x value. Then we do another loop, and we loop until we see that x value. And whatever value that is less than that, right, we swap with another pointer over here. Okay, so they move 3 here. They move 4 here. So it doesn't have to be ordered, right? But it has to be... they have to be before 3. Technically. I know we can cheat and create an array with this, you know, and do, you know, flip our array around or whatever, but we would actually probably just technically sort it and then return it, but I'm not going to do that. We're going to just check out the GitHub, bro. Okay, yeah, it's updating. Contributions. Okay. They even proves that my computer crashed. I have 11 contributions today. There we go. Okay, anyway. Alright. So let's first, let's do, okay. Cur is equal to head. While cur does not equal none. Okay, cur is equal to cur.next. While cur does not, cur.val. Give me the head of a linked list, partition it such that all the nodes less than x come before, but is x unique? I feel like that's a big issue, if x is unique or not in this problem. Because we could have multiple 3s, right? If there's multiple 3s, and are we working with multiple different... let me partition list. Is X going to be unique? Okay, so it's saying that X, there could be multiple X's. I don't know how to do it when there's multiple X's. Yeah, if X has multiple pivot points, I'm not sure how to solve this. How can I solve this problem? Here's some steps. No code. Create 2 dummy neds. Wow, this is such a simple problem. I feel like anyone watching this probably is like, oh, how is this a simple problem? Now that I think about it, we don't even need the pivot point. We don't have to rearrange the stuff around the pivot. We can just find the node, right? We can loop through each node and just compare every node and create 2 separate lists and then link them. Like, bro, how did I not think of that? Like, so we can do, okay, well, okay. We can do, okay, well, cur does not equal none. Okay, we can create 2 dummy nodes, right? So let's do, let's call dummy 1 is equal to, I think it's list node. Dummy 2 is equal to list node, right? Well, cur does not equal null. Okay, if cur.val is less than okay. Oh, my microphone's messed up, guys. Ah. Okay, if cur.val is less than val, okay, then we want to Okay, let's do if code.val is greater than or equal to val, then we can do dummy1.val is equal to val. Dummy1 is equal to dummy1.next. Else, so I guess the bigger list is going to be dummy2. Else, if it's less than that, then we just do okay, dummy1.val is equal to val. Dummy1.next. Dummy1 is equal to dummy1.next. Okay. We built the list. Now we need to connect. Step 2. Connect. Right, so how will we connect? Well, we need to look to find the last node in dummy.val and dummy.val. Right? So while cur does not equal, let's create a new node. Let's do this node. We need to keep the reference to dummy1 now that I realize. So now we need to do, okay, let's do cur1 is equal to dummy1. Cur2 is equal to dummy2. Alright, let's split this up to make it easier to look at. Now we need to fix this, because this needs to be cur2. 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 Cur1. 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 Okay. Now we connect. So we go, okay, do while, let's do find end is equal to dummy1. While find end does not equal cur. Sorry, does not equal none. We check, okay, if find end.next is equal to none, then we make endpoint is equal to find end. Right? So now we gotta find end reference. Step 3. Find endpoint of dummy1, right? We got our endpoint. Now, step 3, we connect that endpoint to dummy2, right? So then we would go, okay, well, okay, dummy3, sorry. I think we do, okay, endpoint.next is equal to dummy1. Right, and I believe, sorry, dummy2. Then we would just return dummy1. The val is not defined. Val is not defined. If not head, return none. Yeah, I'm not sure. Why is this giving me this error? Why are we getting name error? Name val is not defined. What do you mean I defined code? What are you talking about? Change val to X. Oh. Whoops. Maybe make it equal to code.val. Not val. Code.val. So there's no attribute val. So many pointers, bro. It's so confusing. Like, there's no attribute val. Attribute error. It's meant to be list node. Code.val. List node. Code.val. We need a dot next here instead of the val. Because we're actually assigning the val here. On dot next. Oh, we're getting somewhere now. We're getting an infinite loop. Okay. Okay, we're getting infinite loop here because we're not incrementing. Cur is equal to cur.next. That's why we're getting an infinite loop. Okay, we're getting another infinite loop here. Find end is equal to find end.next. There we go. Okay, we got 0. We got 0 here. I guess we don't need this find end because technically we do have the end because cur1 would be at the end, right? So we can just do like cur1.next is equal to dummy2, right? connectors here. Separate two lists. We have a 0 here though. How do we get rid of that 0? Yeah. Oh, bro, it's the dummy 2.next here. That's what it is. There we go. Nice. Good stuff, good stuff. Okay. Let's jump to our next problem. We have a binary tree. Ooh. A few ones we've never done before. I think this will probably be our last problem. I mean, we've been going nearly 2 hours now. Probably would be 2 hours right now, actually, but we're getting through this. Tomorrow we'll be looking at... Oh, man. Mike's messed up again. Technically, we're looking at the binary tree problem. So, oh my god, dude, my hair. Oh. Okay. Let's take a look at the symmetric tree, construct binary tree, some root. Let's do a binary search tree iterator. Oh, jeez, man. I hate these ones. We'll do this one tomorrow. I actually want to do an actual binary tree problem. Populating next right pointers in each node. That's what we're looking at right now, right? No, it's a different one. Let's do some root to leave. I know we've done this recently, about a month and a half ago. You're given the root of a binary tree containing digits from 0 to 9 only. Each root to leave path represents a number. For example, the root to leave path 1, 2, 3 represents the number 1, 2, 3. Return the total sum of all root to leave paths. A leaf is a node with no children. The root to leave path 1, 2 represents the number 12. The root to leave path 1, 3 represents the number 13. Therefore, sum 12 plus 13 is 25. Okay. I think you can do both DFS. Very good question, which can be solved in many approaches. Great suggestion. It is depth first search. Okay. That's what I was thinking. I would have done depth first search, but I thought maybe you could do it using binary search. Breadth first search. Ugh. What we're going to do here is we're going to solve this. I believe we can solve this iteratively. Then we're going to solve it. Looks like we can. Yeah, we can do it both ways. I think that's what I did here. We're going to solve it both ways, right? So let's create a stack, right? We can do, okay, well, while stack, right? We want to pass in, okay, we want our, let's do our root, right? Then we want probably like a current path too or something, right? Like, yeah, probably like some sort of current path, I think. Let's do cur path, right? So while stack, we can do, well, node and path. Let's call it cur path. My current path is, well, nothing, right? Guess we can just pass in an empty string. Equal to stack.pop, right? And then we can check, well, okay. Okay, if it's a leaf, right? It'd be okay. Well, if node dot left, if not node dot left and not node dot right, then we can create some sort of like res array, and we can do, well, res.append copath.
Bro, here, can you hold this for a second? I gotta grab something from the car.
Okay. We probably need to append our current path, right? So cur path plus or equal to node dot val. Okay. We append our res. And then we check, okay, well, if node dot left, then stack dot append node dot left cur path, right? If node dot right, and we stack dot append node dot right cur path, and then we return. Okay, outside of here, let's just like print out res. See what we're looking at right now. String not int. Okay, we need to pass this into a string. String node val. Two arguments needed, right? So let's do this. $13.12, right? So I guess we can actually append this as an int, right? Technically. $1,026, right? Yeah. Okay. Now we can return, well, now we can practice our string comprehension here. So I for I. Okay, let's do, okay, wait, no, it's sum for I in for I in res. That's definitely wrong. Num for num in res. That definitely does not work. Oh, that worked. Okay. We did string comprehension. Nice. Okay. We solved the problem iteratively, right? Now we want to change this and we want to make this recursive, right? How would we do that recursively? Well, let's get rid of all this crap. And let's do, okay, well, let's get rid of all this, right? Start again. Okay, well, we can do stack, right? We still need a stack. We need a DFS function, right? That passes in our root and our current path, right? We can call that down here. DFS, pass in our root and our current path, which is nothing, right? Here we want to change this to node. We don't need a stack because the recursion mimics a stack. Okay, so how do we want to do this recursion? So we probably want to do, okay, well, we need some sort of base case, right? So our base case would be, well, if not, no dot left, and not no dot right, we want to append. We need a res array though outside, right? We need to do, well, res dot append copath, right? As soon as we get the node, we need to create our path, right? So copath plus equal to string node.val. Okay. We append our path, and then we go, well, if node.left, res.append, sorry, no, we call DFS node.left copath. Okay, if node.right, DFS node.right copath. Let's print our res. $12.13. Okay. Then we just, okay, well, we just return num in what did we just do, man? I can't even remember. This stuff is so confusing to me. String comprehension. Okay, in Python. Num for num in res. But instead we need these because we need a summit. Oh, right, we need to, this needs to be an int. Currently we have, yeah, I did the recursive way. Nice. We're at 50 minutes now. Well, technically over 2 hours, but let's jump into another one. Binary tree BFS, right side view. That's a classic, man. Like binary tree level order traversal. I feel like that's too easy. I'm pretty good with BFS, bro. I know I'm gonna solve it in like 2 seconds. Like, let's do the zigzag one, bro. Oh, we solved this one recently. March 27th, about 2 weeks ago. Well, I feel like this is probably the hardest binary. I'm pretty good. I like BFS way more than DFS. I think it's way easier to implement in terms of iteratively and everything. So let's let's take a look here. Given the root of binary tree, return the zigzag level order of its nodes from left to right, then right to left for next level alternate. In the root of a binary tree, return the zigzag level order traversal. 3, 29, 15, 7. Okay. Collections, import DQ, right? We want to make our queue, right? So let's do Q is equal to DQ. We probably want to pass in the root, right? And we want to pass in 0 for the level, right? While Q, we want to check, we want to get the length, right? So the length is equal to the length of the queue, okay? And you know, for I in range length, right? We pretty much just want to build up our cur, right? We need a res array though. And we need some sort of cur, right, for the level, right? For I in range length, we do cur.append I, right? What is 0% to? 0, okay, good. Think about the evens here. So we know that we append I to our current, right? Oh no, we want while Q. Create our length and our cur. We want to pop first, so we need node and level q.pop left, right? We then append our node cur.append bruh. Okay, cur.append node.val, right? Then we also want to check, well, if this is our last value, right? If this is the last value that we appended, if length is equal, okay, wait, no, we want length minus 1 is equal to I, right? We know this is the last value here. We know this is the last value, right? Then we want to check, okay, well, what is the level right now? Is it even or odd? So we check, well, okay, if level %2 is equal to 0, right? Then it's even. We just append, right? Res.append cur, right? Otherwise, if it's false, if it's not even, right? If we return a value other than 0, which means that it's odd, then we have to reverse this. So we would go, okay, cur dot, I think it's reverse. Is there a dot reverse function? Dot reverse Python. Returns a reverse iterator object, right? So we needed some sort of list, okay, right? Then we append that, do cur.append, sorry, res.append, append, check even, then we do, okay, odd. Let's go here, looks better, even, odd, res.append, and we append cur. Let's do like cur.copy. Dot copy Python. Oh my god, copy Python. Okay, whatever. Right. Other than that, if it's not the last value, we need to do, well, if node.left, we want to q.append node dot left, as well as our current level, right? Which would be level +1. If node dot right, q dot append node dot right, level +1. Then we just want to return our, we just return our res, right? Valid syntax, node level is equal to q dot pop left. Cannot unpack tree node object. No, we need this, but maybe I think we need an extra. Why are we code or appending node.val here? Oh, we're building our list. Okay. Takes exactly 2 arguments. Okay. None type. Okay, if not root, we just return that. Nice. Good stuff, good stuff. Nah, bro, I'm good. Top interview 150. Okay, so now we've done our BFS. So binary search, binary search tree. We got our graph, number of islands, evaluate division, course schedule, surrounded regions. Validate binary search tree. Binary tree BFS. Oh, shit, which one did we go to? Bro, which one did we just do? Linked list. Bro, I have to go to my profile. I don't even know what I just did. Okay, what did we do? We did... Yeah, we've done a lot of problems today. 1, 2, 3, 4, 5, 6, 7, done 8 problems today. Jeez, man. Wow. Okay. As you can see, it proves that I was actually doing the problems. I'm kind of pissed still that it reset on me, my computer, but I mean, it's fine. We did some root to leaf, which is in binary tree general. Binary tree BFS. Alright, and that's when we did the zigzag order traversal. Now we need to do a binary search tree. I'm not going to probably continue. Only reason is because I mean I've already done 8 problems today, and I think that's probably enough. Yeah, I'm still pretty pissed that, I mean, I think reset. Let's see where we're at. We're at 329 problems now. Pretty excited about that. Yeah. 96 submissions in 1 year. That's cool. But yeah. I appreciate you guys watching. This video would have been like 2.5 hours, but it's okay. I will see you guys tomorrow. So thank you guys for watching. Bye-bye.